You are ready for the test because this is included in the midterm. So I'll be, inshallah, there will be a regular lecture tomorrow, and I will also take attendance tomorrow. So make sure that you come tomorrow at lecture time, which is 8 or 9 or 10, depends on your section. Is this clear? All right?
Yes.
What I was talking about is when we have, as we said, let me see. Okay. So we have, what's this letter represent in this chapter?
Q, heat.
Q is heat. And what's H?
Heat transfer.
No. What's H? Enthalpy. Enthalpy. You must memorize the name and know the name very well. The enthalpy is potential energy. And the heat is kinetic energy. Kinetic energy. And when you have reactants, here is reactants. And this is products. If you have reactants at higher energy than the product, this is higher energy and this is lower energy, and you're going from reactant to product, this means you're going to lose energy. The heat will come out as Q. So this arrow here is H, and the heat that's coming out is Q. So Q will come out of this reaction, and we call this reaction exothermic. Exothermic. In Arabic, I think we call it طارد للحرارة. Clear? I hope this is clear. It's very important to know everything. That's where the H come from, is from the reaction, and the heat come of the reaction. If the heat come out of the reaction, then we call this reaction exothermic. Exothermic. On the other hand, if this is the reactant and this is the product, this arrow is called what? What's this arrow called?
The direction of energy.
What is it? What is it?
Endothermic.
This is enthalpy. The arrow is the enthalpy. The arrow here is the enthalpy. And what's this? This is the heat. In order to go from lower energy to higher energy, you need to add heat to it. When you add heat, this is called endothermic. Endothermic. ساحب للحرارة. Endothermic, very important. So here the H, which is the enthalpy for the product, is higher than the reactant. And that's why in order to go from the reactant to product, you need to go up. When you need to go up, you need energy to go up. From where you get the energy? From Q, which is the heat that you add to it, and this is called endothermic reaction. Endothermic reaction. Okay. Now, when we agreed that if your system is the reaction, this is your system, and you add heat, and this is anything around it is your surrounding. You add heat from the surrounding to the system. The Q will be positive or negative?
Positive.
It will be positive. Positive. We write it like this, which is exactly mean positive. Or, on the other hand, while here, this is again your system is the reaction, and the reaction was higher energy than product. The energy went down, and the enthalpy went down, and the heat come out from your system to the surrounding. What will be the value of Q in this case?
Negative.
Q will be what?
Negative.
Negative. Why? Because it's coming
Because
out
less.
from the system to the surrounding.
Because
From
we lose.
From system to surrounding. This table you must memorize very well. Don't forget it. Where is it? As I said, this table you must memorize and memorize extremely well. Okay? When we have your reaction is the system, and if the reaction, the energy come out, if it's exothermic process, then Q will be negative. If it is endothermic process, then Q will be positive. Good. All right, we talked about this. Now, when we have a chemical reaction, like this chemical reaction, any chemical reaction, look at this chemical reaction here. You have 2H2O solid goes to 2H2O liquid. Now, if you have ice and you want to make it liquid, do you need to put energy or absorb energy, or the energy will come out?
Absorb. And
What's energy?
Okay.
we need to absorb.
You need heat.
Let me ask you another question. If you have solid ice, which is water, solid, all right, and you want to have it in liquid, which is in higher energy now, the ice or the liquid?
The liquid.
The liquid is higher in energy. So delta H for this one is what? Positive or negative?
Positive.
Positive. Delta H is positive. Why? Because you need to put energy in order to go from the solid to ice. You need to heat it. When you put heat, this means it will be positive. And that's why delta H for this reaction is positive. Good. Now, when we write any reaction like this one, then we know that I always teach you, if I put 1 mole of this one for the reaction, how many moles of this one will make? 1 mole. And what will be the heat? It will be 6.01 kilojoule per mole. Good. Now, if I have only 5 grams H2O, then how much heat I'm going to get, or I need to heat the? If I have only 5 grams of H2O ice, for example.
Multiply it with 6 kilojoule per mole.
No, yes, first you change the gram to what?
Kilojoule.
Mole.
To mole H2O solid. So what should I write here? Down.
18.01.
18.02 gram H2O. The gram H2O will go with gram H2O. And then I know that in this reaction, each 1 mole of H2O solid will need how much energy? 6.01 kilojoule. And so I can tell how many kilojoule we're going to have. So this is how we relate things using the chemical equation. Is this clear? Yes.
How did you get the enthalpy? It's 6.01.
It's given to you. I will give it to you, like
Okay,
this reaction now. Okay, I want you to read this reaction. This reaction, CH4 plus O2 to give you CO2 plus 2H2O, delta H is minus 890. What do you understand?
It's enthalpy is negative, so it is extrothermal.
Oh, very good. First, the enthalpy is negative, so it is what? Exothermic. Right? That's the first information. What's the other information? If I have 1 mole of CH4, will react with what?
2 moles of O2.
2 mole O2 and give you what?
1 mole of CO2 plus
1 mole
2 mole of water.
O2 and 2 mole H2O and this heat, which is minus 890.4. Is this clear? Kilojoule per mole. Now, I will ask you a simple question. If I have 5 grams of H2O produced, then how much heat do we have?
Multiplied by mole over the molar mass.
First, change this to mole, which is what? 18.02 gram H2O. And what should I write here? 1 mole H2O. And then, what's the next?
Minus.
Now, 2 mole down. Why did I write 2 mole here?
Because you have 2.
Because you have in the equation 2. And what's the heat?
Minus
Minus 890.
0.4, and you have the answer. Is this clear? Any question? Good. Next, look at the second reaction. What's the difference between second reaction and first reaction?
Endothermic process, so it's going to be positive.
No, look at the reaction at this time, not the heat. What's the difference between the first reaction and the second reaction? Look at the full reaction. It is what? What?
The opposite.
What?
The opposite.
Reverse it, right? Reverse the reaction, right? When you reverse the reaction, what's the heat of the first one?
Negative.
What's the heat of the second one?
Positive.
What's the difference between them?
The first one is exothermal and the second one is endothermal.
How about the value?
They are equal in magnitude but opposite direction.
Exactly. So when you reverse any chemical reaction, what should you do with the enthalpy?
Change its sign.
What? Change sign. Exactly. Good. Now, if I have CO2, 2 CO2 plus 4 H2O goes to 2 CH4 plus 4 O2, then what will be the delta H? Is it going to be positive or negative?
Multiply by 2. Positive.
What's first? Is it going to be positive or negative?
Positive.
Positive. Why? Because it's the reaction. But what will be the value?
Multiply by 2.
Exactly 2 times 890.4. Is this clear? Very good. So whenever you have a chemical reaction, if you reverse the reaction, then you should reverse the sign. If you multiply the reaction by any value, you should multiply delta H by the same value. Is this clear? I hope this is clear. And I can calculate it for any number from the equation. Let's do this equation. Given the thermochemical equation for photosynthesis. What's photosynthesis? Photosynthesis. What is it? ايش هي؟
البناء الضوئي.
البناء التمثيلي ايضا يسمونه ولا لا؟ مو التمثيل الضوئي؟
هو حقة النبات.
نعم.
اي لا، البناء الضوئي.
ها؟
البناء الضوئي.
البناء الضوئي والتمثيل الضوئي، والله ما ادري، انا كاني سمعت قبل التمثيل الضوئي او البناء الضوئي. نعم، البناء الضوئي. This is called photosynthesis. The plant take water from down and CO2 from the air and make sugar and then give us O2 gas out, and it needs 2,808 kilojoule per mole. From where the plant get this energy?
From the sun.
Exactly.
From the around.
Okay, if we have 75 grams of sugar, then how much energy do we need?
Change it to mole.
Exactly. You have to go to your periodic table and find what's the mass of this one from the periodic table. It's given to you here. It's 180. So what should you do? Multiply by what?
1 mole.
1 mole.
Sugar.
6 إلى آخره, and there here 180.2 gram C6 إلى آخره. بعدين what's next?
Change it to kilogram per mole.
Each 1 mole C6 H12O6 will give me what? Or need
2,080
kilojoule, and this will go with this will go with this, and you can have the answer. What's the answer? Quickly.
0.416.
0.
1166.05. I got this number.
1,166.05. Very good. That's the answer. That's good. I hope everybody got the same answer. Is this clear? Good. All right. Next, we'll define here specific heat and heat capacity. Okay, specific heat we will represent it by S, and heat capacity we represented by C. I want you to write these two letters. Specific heat we're going to represent it by the letter S, and heat capacity, which is C. All right, and we're going to talk about calorimetry. Calorimetry. What's calorie means? You remember calorie? What? Calorie is related to what? Calorie, energy, right? And when we say meter, what do you understand from meter?
Measurement.
Measurement, exactly. So what are we going to do with the calorimetry?
Calculate the energy in the food.
Measure energy, exactly. Measure energy. Okay, good. This is the heat capacity. We're going to represent by the letter S. Heat capacity, we're going to represent by C. What's specific heat? Specific heat of a substance is the amount of heat required to raise the temperature of 1 gram of any substance by 1 degree C. So if you have 1 gram of anything, 1 gram of anything, let's say at 25 degrees C, and this is 1 gram, then you calculate how much energy to make still 1 gram, but you make the temperature what? 26 degrees C. Then the amount of energy required to raise this temperature is called specific heat. Is this clear? Okay. The heat capacity is exactly the same, but it's not for 1 gram, for anything. So if we have any object, I don't know what's the mass. I don't care about the mass. All right. But I know if I raise the temperature by 1 degree, if this is at 25 degrees C, and this is 26 degrees C, how much energy do I require to heat this object by 1 degree, same object here? Then this is called heat capacity. So the heat capacity, amount of heat required to raise the temperature of any object by 1 degree C. Is this clear? Okay, good. But this is, what's the difference between specific heat and heat capacity? The specific heat is what?
Depending on the mass.
It is for what?
Only 1
mass.
gram.
Only 1 gram. Only 1 gram. While for the heat capacity, for any amount, for any mass. Is this clear? Now, the heat capacity of water, and I want you to know this, even though, as I said, it's available for you in the periodic table, but the heat capacity of the water is 1 calorie per gram, of course, and per degree C. I want you to know this, and you know the value exactly. All right? This is the calorie for water. Did you see this unit before? Calorie, what is it?
It's kilocalories.
No, that's, sorry, I wrote it capital, it should be.
4.184 joule.
I mean, small calorie, which is exactly 4.184 joule per gram degree C. Is this clear? As I said, this is available for you in the periodic table, but you have to memorize it. Even though it's available, you don't have to keep it 100% in your mind, but try to memorize it. Any question? Now, when we want to measure the heat for any substance, it's equal to the heat Q is equal to, okay, tell me, Q for any, for the water, what is it? What's this?
Heat.
Specific heat.
Specific heat.
Heat. What's this?
Mass.
Mass in gram. What's this?
Change in temperature.
Change in temperature. What's the unit for S?
Joule
Per gram degree Celsius.
Good. What's the unit for mass?
Kilogram.
meter. A kilogram.
No, we'll use gram this time. All right. What's the unit for the delta T?
Celsius.
So what will happen? What's the unit for E?
Joule.
Or Q, sorry, not the unit for Q in this case. Is this clear? Same thing with heat capacity. The unit for the heat capacity C is what? Joule per degree C only. There's no gram. As I said, it does not depend on the mass. And of course, delta T is in degree C. So what will be the unit for Q? Is this clear? Any question? Good. This is a specific heat. Don't memorize any one of them. Even water, don't memorize it, but it's very important. Keep it in your mind. The others, I don't know it. What's the specific heat of aluminum? I don't know. I have to look at the table. Is this clear? Even water, you don't have to memorize it, but if you want, you can memorize it. I think it's a good idea to memorize 4.184. Good. Calculate the amount of heat required to heat 255 grams of water from 25.2 to 90.5 degrees C. Go ahead, solve this problem. Don't forget. What's this? 255, what is it? What's this? 255?
The mass.
Mass, okay. What's the specific heat of water?
4.184.
I wanted to memorize this. The specific heat of water. Then
Because 69 .6 kilojoule.
Oh, you have the answer? Very good.
Yes.
Okay, first, what's delta T? Calculate delta T. What's the difference between the two temperatures?
65.3.
What's the answer? What's Q?
It's
69.6 kilojoule.
69.7 kilojoule exactly. Yes, it is true. Very good. Excellent. That's the answer. Okay, the first calorimeter that we are going to talk about is called constant pressure calorimeter. So it's to measure, it's a calorie, and it's a very simple instrument. What is it? It's a coffee cup. You know the coffee cup? This is styrofoam cup. Coffee cup. This is simply coffee cup, which is styrofoam اللي هو الرغوة هذا because it's a good insulator. Okay, and this is what you need. Other than that, you need a cover for it, and then you need a thermometer. And you make your reaction. In here, your reaction is your system, and the water is what? Surrounding. All right? And when you make the reaction, if the reaction is exothermic, what will happen to the temperature of the water?
Will rise.
Increase.
Exactly. If the reaction is endothermic, what will happen to the temperature of the water?
Decrease.
Increase.
Decrease. It will be lowered. Okay. Q for the reaction, Q for the surrounding, which is the water, is equal to S times the M times delta T. But for the reaction, you have to put minus for it. Because when the heat is exothermic, this means Q should be negative, but for the water, it will be positive. It's the reverse of this sign. So for the Q of the water will be positive if it is exothermic, and this will be negative. On the other hand, if the reaction is endothermic, then the heat of the water will be lowered, and Q will be as is, but the value will be less, and then this will be up. Good. Let's solve this problem very good, very quickly. We have here a metal pellet. So we have the same cup, which we just do. This is the cup calorimeter, and we have the temperature here, and we have metal pellet, a piece of metal with a mass of 100 grams. So we put 100 grams originally at 88.4. So the metal was 100 grams and it was at 88.4 degrees C. Okay, it's dropped in water. This is our surrounding water. It was 125 125 gram of water, originally at 25.1. 25.1. Of course, this is more hot than the water. So when you put this billet on water, what will happen to the temperature?
Will decrease.
It will
And
increase.
the water increase.
Yes, the final temperature is 31.3 degrees C. Can you calculate what's Q of water? Quickly. Don't forget that the specific heat of water is what?
4.184.
Exactly. Okay, tell me what's Q of water. Quickly.
It is 3,242.6.
Minus دكتور.
No, is it positive or negative? Oh, good point. Is it positive or negative?
Positive.
It is positive. Why positive? Because the temperature raised. This means it absorbs energy. So it should be positive. And what is it equal to? It's actually equal to 100 times 4.184 times what? 31.3 what?
Minus 25.1.
25.1. That's it.
Doctor, it should be 125 gram or 100.
Doctor, 125 gram.
125.
Yes, you're absolutely right. Sorry, yes, I am wrong. Yes, of course, it's 125, of course. 125, yes. Yes, I was looking at this 100 gram. Anyway, yes, so what's the answer now?
3.24 kilojoule.
3.24.
24.
Who got the same answer?
But in kilojoule, yes, that's true.
Yes,
Okay.
right.
Good. So let me ask you a simple question now. What is Q for the billet? Actually, yeah, Q for a billet.
The minus.
Will be
Minus.
Exactly. It's the same value, but with a negative sign, 3.24 kilojoule. Excellent. Now, what is the specific heat of the pellet? What should you do? You should say that
دكتور
3,240 equal to what? I want to change it to joule. Equal to what? 100 gram times specific heat of the billet, which I don't know, times what?
Change in temperature.
31.8, 31.3 minus 88.4. Because always the change in temperature, you start with the final minus the initial. And then this will be negative like this one. Okay, then what's the value of S?
Minus 576
Oh,
points.
positive. Not minus will go with the minus. The minus here will go with the minus here. So
Okay, so it's 567.88.
I got it as 1,839.
0.56.
do 3,240 divide by 100 and then divide by the difference in temperature.
Yeah,
0.5.
0.5.
Yeah, it's 0.57 دكتور.
0.57. I believe this much more. Is this clear? 0.57. Is this clear how you do these problems? It is.
Doctor, I got 1.76.
7. It's 57. So not 0.57. It's 57.
Sir,
Yes.
why the water heat and the emitted heat are equal? but different sign.
What's your question?
Why the water is equal to the metal heat, but different sign?
Of
I
course,
didn't get that.
because the water is the surrounding. All the heat from the system, your system here is the billet. All the heat from your system goes to the surrounding. And first law of thermodynamics is that all the heat that will come from the billet will go to the surrounding, which is the water, with a negative sign. That's it. Is it clear?
Doctor.
Yes, yes.
Yes.
He asked for the specific heat, not heat. He asked the capacity.
He asked for the heat capacity. Yeah, it's different from the specific heat.
Thank you very much. So yes, the specific heat is 0.57. All right, but the heat capacity is 57. Exactly. Thank you very much. Is this clear? Is this clear to all of you?
How do you know the heat capacity, Doctor?
The heat capacity, we don't care about the mass. That's why the mass was 100. I multiply by 100 by the mass, or the whole mass. So the specific heat was 0.57, but the heat capacity, which is, I don't care about the mass, so I'm not going to divide by the mass, so it will be 57. As we said, don't forget that Q equal to mass times specific heat times delta T, or Q equal to specific heat, heat capacity times delta T. What's the relation between specific heat and the heat capacity? What's the difference? What's the relation?
The mass.
C equals
C equal to the mass times specific heat, if you calculate specific heat. Is this clear?
Yes.
Okay, I hope so. Good. Okay, next. Okay, these reactions are very important. What do you call neutralization? When we say neutralization, what does that mean?
Acid plus base equal water.
Exactly, acid plus base to give you water and salt. And this is the heat. All right, don't memorize the heat, but this is the heat with heat. We call this heat of neutralization. What's ionization means?
Switching ions.
To change to ions, and this is called heat of ionization. Heat of ionization. What's the heat of fusion?
Change the physical state from solid to liquid.
From solid to gas to liquid. What's the heat of vaporization?
Changing the state from liquid to gas.
Exactly. So I can give you a question and say that, for example, the delta H for a reaction is equal to X, which is, it is for the delta H is equal to X for the vaporization of mercury. So what's the reaction?
Mg liquid equal
Hg liquid goes to what?
Mg gas.
Hg gas. And what's delta H for this case? Is X, which I gave you here. So I can give you X without saying what is the reaction. I'll tell you it's vaporization, that's all. And you have to do it. Is this clear? Okay, good. Next, the other calorimeter is called volume, constant volume calorimeter. Yeah, by the way, I forgot to say this. This is constant pressure calorimeter. And we said that constant pressure, we represented by the letter QP. QP equal to what? Delta H. So in this reaction, when we make this reaction, we're going to calculate delta H. QP is equal to delta H because it's constant pressure. Constant pressure. We'll go back long time. You remember we said that QP equal to QH, delta H. But QV equal to what? QV means constant volume is equal to delta U. But constant pressure, QP equal to delta H. We said this long time ago. Now, when you have this reaction, we're calculating QP, constant pressure, because the pressure does not change. And that's why when we do this calculation, we are going also to calculate delta H. It's the same thing. But when we have this instrument, this is called bomb. Write the name, bomb calorimeter. Write the name. What's bomb means? What's the meaning of bomb?
مضخة.
لا.
قنبلة.
قنبلة.
Bomb. Bomb. Bomb calorimeter. Clear? Good. And here, this is the instrument. You don't have to know much about it. But in this thing, you have the reaction in here, and you make the reaction with electrical ignition. This means you put electricity and make the reaction, and the heat will go all to the water and to the system. And I will give you C for the whole calorimeter, or C for the whole calorimeter, or C for the solid thing, C calorimeter plus C of water, H2O. All right, I can measure both of them. Okay, same thing. Then Q of calorimeter is minus Q of reaction, and Q of calorimeter is equal to specific heat of the calorimeter times delta T, and Q of reaction is minus. It's the same thing, same value, because with different sign, that's all. Okay, a famous Amos bite-sized chocolate chip. We have a chocolate chip cookie, okay, weighing 7.25 grams, is burned in a bomb calorimeter to determine its energy content. The heat capacity of the calorimeter, so we have C is equal to 39.97 kilojoule per degree C. Okay, and then during the combustion, the temperature of the water in the calorimeter increased by 3.90 degrees C. Calculate the energy content in kilojoule per gram of cookie. All right. So what's Q of reaction? Well, Q of calorimeter.
C delta T.
Yes, we usually write it Q cal. So when you see Q cal, what should you say? It is C delta T. Simple. Okay, give me an answer.
Teacher, what is the initial temperature here?
Okay, good question. Should we know what's the initial temperature?
No, because he gave
he delta T. He gave us delta T.
Because it was increased by. So whatever it was, let's say it was 10, then it went to what? Increased by 3.9. So if it starts with 10, it will be at the end 13.90. Is this clear? So it's already given to you as delta T. You don't have to know the original or the final.
Doctor, the answer will be 155.88.
1.55 9 times 10 to the power 2 kilojoule. Good. So what's the, this is come from, what's the Q of reaction? Q of reaction, Rxn.
Minus.
Same thing, minus 1.559 times 10 to the power 2 kilojoule. Good. Then what is it per gram?
21.5.
Yeah, you should divide this number by the mass, which is 7.25, and you have the answer as 21.5 kilojoule per gram. That's it. Very good. All right, next. Let's go to the next subject. So, yes, you're absolutely right. The answer is right. Next, Hess law. Hess law. Very important law that you should know in thermochemistry. Very interesting and very important law. Okay, what is Hess law? Hess law, if you have reactions, like we have here group of reaction. I'll call this one 1, I'll call this reaction 2, and I'll call this reaction 3. All right? Now, if I take the first reaction and write it as it is, I will write it on this side. Let me get rid of. I will erase this. And instead, I'll call this one reaction 1, reaction 2, reaction 3. Okay. In reaction 1, reaction 2, and reaction 3, I have these 3 reactions, and I know what's the reaction. This is the heat of the first reaction, this is the heat of the second reaction, and this is the heat of third reaction. And I want to calculate what's the heat of this reaction down here. I don't know what is the heat for 4, what's delta H, I don't know, and I want to calculate it. What should I do? For the first reaction, I will keep it as it is. So I will write NO plus O3 to give you NO2 plus O2. Okay. Then I will take the third reaction and I will reverse it. If I reverse it, what will happen?
The sign of enthalpy will change.
Exactly the sign. So for this one, delta H is exactly the same, no change at all, because I wrote it as it is for the first one. For the second one, I will reverse the reaction. Not only I will reverse it, I will also divide it by 2. So what should I write? Reverse it and divide by 2. What should you write? What's the reaction? Then it will be O plus what? That's it. O goes to what?
Half O2.
Half O2. And what will be delta H?
495 over 2.
First I have to minus 495 divided by 2. Is this clear?
Why did we divide it by 2?
I will tell you in a while. Okay, why? I will tell you. Good. Next thing, I want also just simply to reverse this reaction. I want you to reverse the reaction 2, reverse it. What are you going to write? 3 over 2 O2 goes to what?
O3.
O3. And what will be delta H?
142.
Is it positive or negative?
Positive.
Positive 142.3. Clear? Good. Now, anything available, reactant and product, cancel it. Look at the first, the 3/2O2. It's available 3/2O2. Available in reactant in this side, right? But there is O2 in product and half O2 in product. If you add O2 with half O2, what are you going to get?
3/2O2.
Then I will get rid of this with this one and this one. Anything in reactant and product, I'll cancel it. Okay. Now, what's next? I also have O3 in this side and the reactant. And I have O3 what?
Product and the second one.
Cancel them with each other. All right? So let's, whatever is left, keep it as it is. NO will come down. And then what do we have? O will come as a reactant.
And O plus O.
And NO2 will be.
NO2.
That's it. So I played with these reactions so that I cancel it and I have the final reaction like this. Is this clear? What will be the energy of this one? Now you add this one, we did not do anything to it, so I will keep it as it is. So 198.9, what's the sign? Negative. Plus what?
142.3.
142.3. And then minus
495
over 2. Calculator, give me the answer.
Doctor,
Minus 304.1.
304.1. Let's hope so.
Doctor, I only cancel if I have one in the product and one in the reactant, right?
Yes. No, you don't have. I mean, if you keep half, you can have. See, for example, in here it is 1 to 1, but in this one we have 3/2, and here half. So we cancel only half with half, but we're left with 2/2, which is 1, and then we cancel the 1 with the other one, which is this one. So you can cancel only half with half.
I mean, if I have both in the product, I can't cancel it. I need to flip it to cancel.
Of course, exactly. You need to flip it to cancel. What I'm trying to do, I want to use this reaction 1, 2, and 3 to get to the fourth reaction. That's the idea. Is this clear? This is called Hess law. Hess law.
Doctor?
Yes.
The enthalpy system will be minus reaction enthalpy.
What again?
The enthalpy system will be minus enthalpy reaction, which is a 3.3.
All of them are systems, so no, it will be the same number. All of these are considered to be system now. This is the heat of reaction. It's the heat. This is so enthalpy. This delta H is the enthalpy of reaction 1. This is the enthalpy of reaction 2. And this is the enthalpy of reaction 3. And what I did, I reversed them and play with them so that I have the final answer like this. So for the first reaction, no change at all. For the second reaction, I reverse the sign because I reversed the reaction without doing anything. For the third reaction, I reversed the sign and divide by 2. And that's why I have this number, and delta H for this reaction is 304.1. Can you do that? Good. So, yes, you are absolutely right. The answer is 304.
Doctor.
Yes.
How can I play with them correctly?
That's the art. That's how you should do it. You get it? I want you to play with it so that you know how to do it. Any question? I mean, This is the art of solving this problem. See, in the first one, no change at all. The second one, reversed. And the third one, reversed and divide by 2. And that's why we have this value. And then we add whatever numbers we have, we add them together, and we get the delta H for the final reaction, which is question 4. I hope it's clear.
For the second, why you didn't multiply by 3/2?
Because I want to get rid of this O3 with 1 O3. I did not want to change it because I want it 1 to 1. I want whatever available reactant to cancel with whatever available product.
Okay.
Okay, and the same thing with O2 here. It's 3/2. This means 1.5. I have 1 here. This is 1, and this is half here, 1.5. And so I cancel this one with both of this one, and this one. Is this clear?
Yes.
Okay, very important. And again, usually in the exam, there will be at least one question like this one, in which we give you 3 reactions, 1, 2, and 3, and ask you to find what's delta H for another reaction. And this is called, this whole process is called what? You have to memorize the name.
Hess law.
Hess law, the name of scientist Hess. Don't forget it. Good? Done. Next, standard enthalpy of formation. From now on, I'm going to talk about also heat of formation. Heat of formation. What is heat of formation? What is formation? What's the meaning of formation?
The heat with the تكوين action.
تكوين, yes. تكوين. Heat of formation means حرارة التكوين. All right. And what do you mean by heat of formation? I want to know how to make any compound. But I have to, and this is we call the standard, and that's why we put a circle like this on it. Is this clear? Good. Heat of formation, we put a circle in the top. We will agree now that heat of formation. Do you have the periodic table? I want you to have the periodic table in front of you, and because I don't want you to look at it. Now, anything available in the periodic table, you should know. You remember, I hope I have colored periodic table, but the heat of formation of any element available in the periodic table, like for example, if I say Na solid or K solid or Fe solid. All right, anything in the periodic table, I write it with this thing, the heat of formation for this element equal to 0, because these are the basic element, how available. We mean by heat of formation, we will agree that the heat of formation of the elements in its naturally occurring state is 0. That's the meaning of heat formation for element. So the heat formation of element, how it is available naturally. occurring state is considered to be 0. Sodium is available as solid. K is available as solid. Fe is available as solid. Okay, everything is almost available in solid, but there are some gases. What are the gases now? This is heat formation, also equal to 0 for the gases. What are the gases? Which is noble gases, like for example, helium. What's under helium? Periodic table.
Neon.
Neon gas. What else?
Argon.
Argon gas. What else?
Krypton.
Gas. What is
Neon.
it? Xenon gas. You don't have to go further. Very good. What else we have as gases? We also have N2 gas. Look, nitrogen is available as what? N2. How about oxygen?
And hydrogen, doctor.
Sure. Hydrogen gas.
Doctor, why N2?
What else?
Halogens, all gas or?
No, F2 gas. What else? Cl2 gas. Is this clear?
Doctor, why we have 2 on some of them?
How is oxygen is available naturally? Because we're talking about naturally occurring. What's the meaning of naturally?
بشكل طبيعي.
في الطبيعة. All right. How is oxygen available in the nature?
O2.
How about nitrogen? How about hydrogen? H2. How about fluorine? F2. How about chlorine? Cl2. You have to memorize these gases. These are available as gases. Then you have to memorize it. Okay, how about liquid? Liquid we have, I want you to memorize only Br2. Br2 is available as liquid.
Mercury also.
What?
Mercury.
Mercury is available as liquid. You have also cesium, which is in the alkali group, is available as liquid. All right, that's all what I wanted to know from the liquids. Is this clear? Okay. How about the rest? It will be all solid. And if you have one element in solid, then what's delta H? So what is delta H of formation of sodium solid?
0.
Delta H for potassium solid?
0.
What's the specific heat of O2 gas?
0 also.
0. How about platinum solid? What is going to be? 0. All right. How about palladium solid? Anything. It's all like this. I want you to memorize these elements. Is this clear?
Only this?
No, yes. For gases, these are the gases. You have to memorize gases and liquid only, but the rest is available in the periodic table. You know that they are solid. They are not gases nor liquid, so they will be solid.
Cesium, doctor.
What?
Isn't solid cesium?
Yeah.
It's in the group 1, right?
Yes, but it is liquid, naturally available as liquid.
Because in my periodic table, it's like solid.
No, it is liquid. Look, I mean, if you have colored, they will put blue color for it, not solid. Is this clear? Now, what is the heat of formation? The heat of formation is the energy required to make any element from naturally occurring element. So, if I want to know what's the heat of formation of H2SO4, for example, then I need to make this compound from naturally occurring elements. So what I should do? No,
H2.
let me give you more simpler one first. Let's start with, is this?
Recombination, right?
No, I want to define what's heat formation. Heat formation of H2O, for example, liquid, is the heat required to make H2O liquid from naturally occurring elements. So how can you make water from naturally occurring elements? This how the elements are available in the nature.
I have H2 and O2.
I need to put this as one always. So what's the reaction? It will be what? H2 what? Gas plus what?
O2.
O2 gas, and then I need to balance it to make one here, so I need to multiply this by half. That's it. That's the heat here. What's the heat of this reaction? What's delta H for this reaction? Is equal to heat of formation of what? This heat of this reaction is equal to the heat of formation of H2O. Why? Because we are making water from naturally occurring elements. Let's do the same thing with H2SO4. Can you help me? Liquid. Can you make it? What's the heat of formation? First, what's the number should I put here?
1.
1. Okay, what's the reactions?
H2 plus H2 gas.
Gas
plus a solid.
S solid, fantastic. Plus
O2 gas.
O2 gas. Only O2?
2 O2.
Yes.
Multiplied by 2.
O2, exactly. So what's the heat of this reaction?
Delta H.
So what's the heat of this reaction equal to? Heat of what?
Heat of formation of
Is this clear? Clear? So I want to define,
there is no number.
Define what's heat of formation.
Is it 0?
What's the meaning of heat of formation? No. The heat of formation for these are not 0. For these they are 0, but for this one it's not 0. There will be certain heat. What's the heat of formation? Define it. Is the energy required to make what?
To make the reaction,
To make a compound from naturally occurring elements.
Exactly. To make a compound from naturally occurring elements. Naturally occurring elements. So this is the enthalpy, standard enthalpy of formation, which is the heat. Read very well. The heat required to make the change to result in what? 1 mole of product from what? Formed from its constituent element in their standard state or naturally occurring. Is this clear? That's the meaning. Good. Now, very important also that we can, then the heat of formation was calculated for so many elements. For example, so you will find that the heat of formation, like this heat of formation, was calculated for so many elements, like this one. And this is the heat of formation of this one. And this is the heat of formation of water. If I ask you to write the equation for the heat of formation of water, what are you going to write?
H2 plus O2.
Gas plus
O2.
O2 gas times half to give you 1 mole H2O. What will be the delta H of this reaction? It's this number. The heat of formation was calculated and it is minus 285.8. Is this clear? Next, let's do it for this one. What's the reaction that you're going to write for N2O2?
Na solid
plus
O2 gas
to give you
1 Na2O2.
Na2O2. What will be the heat?
You should multiply 2 for the solid.
Exactly. Don't forget this. This is equal to minus 410.9. I hope this is clear. Also, another information, delta H for any reaction, this is very important. You have to know this thing. Delta H for any reaction is equal to the summation of the heat of formation of product, summation of heat of formation of product minus the heat of formation of reactant. You have to memorize this equation as well, this equation. So if you have any reaction, like this reaction, then what's the heat of the reaction is the summation. What's N here? What's N?
Mole number.
Number of moles, okay, which is the coefficient in here. N and M are the coefficient available in the thing, and then this is the heat of reaction and product. Let's do a problem and then things will be clear. For example, if I have this reaction, if I give you the heat of formation of Ag, the heat of formation of AgCl and AgCl, they are minus 105.9, minus 167.2, and minus 127.0. Don't forget that delta H of reaction is equal to, you keep the product as it is, but for the reactant, what do you do? Minus
Some of them.
H reactant. Clear? Minus. Good. So what will be the delta H for this reaction? What should you do?
Summation of the
For the AgCl, you keep it as it is. So what is it?
minus 127.
Minus 127.0. Should I multiply it by any number?
number of moles.
1.
Which is in this case all of them 1. So I'll keep it as 1. And then what is it? And then minus
open brackets.
For, yes, I can open brackets, okay. For, what is it for Ag? 167.2, and then minus also 127.0. Okay.
Dr. 105.9.
Plus 105.
Plus 105, Doctor.
Oh, sorry, yes, you are absolutely sorry. All right, so this is 105.9, and then you have the delta H reaction. Give me the answer.
Isn't it plus 105?
Should be plus, Doctor. Or...
Oh, it's in parentheses, it's all the same. Then I'll multiply it by plus over the minus, and it will be all plus. Exactly. I put them as it is, but I will multiply them at the end by minus.
That is in the original equation, plus.
If you go back to the law, Doctor, it says plus.
Yes. It is plus. I'm sorry. Yes, you're absolutely right. I am
minus 65.7.
Exactly. So I can calculate the delta H for this reaction by this number. Is this clear? Okay, as usual, I stop here. We have to do the
Doctor.
Yes.
Have you finished chapter 5?
Yeah, well, we finished it, but we did not do the problems with the heat formation. Tomorrow we will discuss it one more time. But yes, we finished chapter 5 actually. All right. So please go to the the forms and
Send the link, Doctor.
I will send the link, and please, no excuse, go to the chat of Microsoft. This is Control V. It is already sent to you now, and then I will open it, setting, accept responses. Okay, go ahead and do responses quickly.
Closed دكتور.
فتح جرب مرة ثانية. افتح.
افتح سكر وافتح، لازم تسكر وتفتحها مرة ثانية.
سير ريفرش الصفحة.
ريفرش يا عيال بس.
ها؟
دكتور الرابط ما ظهر عندي لين الحين، ده ممكن ترسل مرة ثانية؟
Okay, one more time.
دكتور أنا برضو نفس الكلام يا دكتور.
I resend it. Done.
الدكتور والله ما طلع عندي الحين. شباب أحد يرسل واتس.
موجود على الواتس.
الشات حق الميتنج.
مو برا.
مو طالع لي. دقيقة برسل رسالة هنا.
روحوا للشات يا شباب. شات.
أحد شايف رسالة حقتي؟
ايوه.
شايفينها
طيب ارسلوا هنا في نفس الشات هذا.
موجود في الواتس برضه.
دكتور I have a question.
Yes.
الجروب. أرسلت لك. Can you go to the slide page?
خلاص يا شباب.
دقيقة دكتور قاعد اسجل دخول.
دكتور please. I have a question.
Okay, I'm going to be here for the office hour, but I need about 5 to 10 minutes. I'll go out and then I'll come back, inshallah. All right يا شباب؟
اوكي.
فخلصتوا من التحضير؟ I hope so.
خلصت أنا دكتور.
لا دقيقة دكتور ثواني بس.
يلا يا شباب.